Hey guys, welcome back to Code Streak Daily, where we break down complex coding problems and provide you with easy to understand solutions. So today in this video we are gonna solve the Leetcode's problem. The title is Cousins in Binary Tree 2. So here we have the problem description. Given the root of a binary tree, we have to replace the value of each node in the tree with the sum of all its cousins value. Two nodes of a binary tree are cousins if they have the same depth with different paths with different parents. Return the root of the modified tree. Note that the depth of the node is the number of edges in the path from the root node to it. So let's take a look at this binary tree. This is the root and it has two children 4 and 9. 4 has two children 1 and 10. 9 has one child 7. Okay, so here 5 is the parent of all the nodes. 5 is the parent for 4 and 9. 4 and 9 will be siblings because they do have the same parent. Here 4 has two children 1 and 10. 1 and 10 will be siblings because they have the same parent 4. Whereas 1, 10 are siblings and 7 is the cousin for 1 and 10 because their parents are at the same level and they have different parents. Okay, and these are also at the same level. We have to see two nodes of a binary tree are cousins if they have the same depth with the different parents. These have the same depth with different parents. Okay, now we have to replace the value of each node in the tree with sum of all its cousins. Okay, 5 do not have any cousin, so we will replace the value of 5 with 0. 4 do not have any cousins, so we are replacing the value with 0. 9 also do not have any cousins, so we are going to replace the value with 0. Whereas 1 and 10 have the cousin 7, so we are going to replace the values of 1 and 10 with 7, and 1 and 10 are the cousins for 7 as well. So we are gonna replace the value of 7 with the sum of both these nodes, 11. Okay. Uh, Take an example. If 9 also has another child, for example, say 3. Therefore, these two will be replaced with 10 and 10 because the sum of these two nodes will be 3 and 7 will be 10. So we're gonna replace 1 with 10 and 10 also with 10. Then we're gonna replace 3 and 7 with 11 and 11. Okay. Now take a look here. Here this is a binary tree with two children. They do not have any cousins. So we are going to replace all these values with 0. That's it. This is basically a commonly asked question in technical interviews. So make sure to watch till the end. Okay. So the problem is fairly straightforward. We have to replace the values of each node with its cousins. That's it. Only that's it. Now let's move into how we can solve this problem programmatically using the Python. Okay, we'll solve this problem using the breadth first search technique (BFS) to process the tree level by level. At each level, we'll calculate the total sum of the node values, and then for each node, we'll subtract its siblings values to find the cousin sum. Okay, let's break it down to simple steps. Uh, Before going to enter into the code, here we have a class tree node with a function defined in it, and there are values here. Self.val equals to val, self.left equals to left, self.right equals to right. This is how the node is initialized. Okay, we have another class solution with the function replace value in tree. We have the tree root of the tree passed, and we have to return the value. That is, we are also going to return another tree, binary tree. Okay, now before starting, I'm gonna import dq. I'm gonna use the data structure dq from collections, import dq. Okay, first we have the class tree node set. We also have the class solution. Okay, now in our replace value in tree function, the first step is to handle an edge case where the tree might be empty. If root is none, then we are gonna simply return none. So if not root, in this case, what we are gonna do? We are simply going to return None. Next, we initialize a queue for BFS and add the root to it. The root node does not have any cousins, so we set its value to 0 immediately. Okay, so Q equals to DQ. I'm initializing the BFS with the root. Okay, and the root does not have any cousins, right? So root dot val equals to 0. As root has no cousins, the value will always be 0. Now, we move to the BFS traversal. We process the tree level by level. For each level, we have to determine the number of nodes at the level using the level size. Exactly. And next, we are going to initialize the total sum to store the sum of node values at this level. Next, we store all the nodes in the level nodes to process later and also add their children to for next level. Okay. So this might sound similar like the problem we have done yesterday. Okay, next while q. So I'm taking the variable level size. What we are going to do? We are going to find the length. That is how many nodes are there. Next, I'm taking the variable total sum equals to 0 and I'm taking a variable level nodes equals to an empty list. Okay, this is going to collect all the nodes. Okay, so next we are going to collect all the nodes. For that, I'm taking a for loop for underscore in range of what? Level size for underscore in level size. We're gonna take a variable node equals to q dot pop left. Okay, then we are gonna append this node into level nodes. Okay, level nodes dot append. What we are going to do? We are just appending the node. Next, we are going to add child nodes to the queue for the next level. Okay, then here we are gonna check if the uh, node has left child as well as right child. Okay, so for that, if node dot left, exactly the process we are doing as in the previous Leetcode video yesterday, we have done that the same procedure. Q dot append of node dot left, and if there is a right child as well, Q dot append node dot right. Next, we are going to calculate the cousin sums. Once we have all nodes at the current level, we'll calculate the total sum of the nodes for this level. We check if a node has a left or right child and add its value to the total sum. This will help us to calculate the sum of cousin nodes later in the code. Okay. So for that, for node in level nodes, what we are going to do? If node dot left total sum, we are adding it node dot left dot value. If there is a right node as well, if node dot right, if node dot right, in this case also we are adding that node dot right dot val. Next, we are going to update the node values. Alright, this is the key part of the solution here. First, for each node, we will calculate the sum of its siblings, that is left and right child. Then, to get the sum of cousins, we will subtract this sibling sum from the total sum of the level. So, therefore, we will get, if there are any cousin values, we will get that as the difference. If there are no cousin values, we will get the total answer as 0. Okay. Now, finally, we'll update that left and right children's value by setting them to total sum minus sibling sum. Okay, this ensures each node is replaced with the sum of its cousins. So, for node in level nodes, I'm taking a variable sibling sum which is initialized to 0 If node dot left, if there is a node left node, then what you are doing? Sibling sum, we are adding it, right? Sibling sum equals to node dot left dot val. If node dot right, in this case also sibling sum equals to node dot right dot val. Okay, so we are gonna update the left child if it exists. Okay, if node dot left, then node dot left dot val equals to total sum minus sibling sum. Okay, if there exists right node also, if node dot right, then node dot right dot val equals to total sum minus sibling sum. Okay, that's it. Next, we are gonna return the root. That's it. Is this where I have to return? Yeah, return root. After processing all the levels of the tree, we return the modified tree with the updated node values. Okay, now let me run the code and check. Okay, there is a typo. That's it. Don't worry. Okay, total sum is not okay. There are typos. That's it. Okay, we have both the public test cases passed. That's it. Now let me submit the code and check if all other test cases are being passed or not. Yeah, our code passes all the test cases and we have an achievement again. Our code beats 97.20% of users. That's a good number because as you can see the graph over here, there are very less numbers. Okay, so our codes is just 130, right? So we have like around 0.35% of users. That's it. So that's a very good number to beat, and we have a runtime of 130 milliseconds, right? So that's how we solve the problem of replacing each node in a binary tree with the sum of its cousins. Using BFS, we traverse the tree level by level, calculate the total sum of each level, and then subtract sibling values to get the cousin sum. Okay, let's summarize the approach, how what we have done here. Perform BFS to travel the tree level by level. At each node, calculate the total sum of the node values. For each node, subtract the sibling sum from the total to get the cousin sum. Then update the node values and return the modified tree. Okay. I hope you found this video explanation helpful. Please do subscribe to CodeStreak Daily for these kind of videos regularly. And if you like the video, please do hit the like button. And if you have any questions, please do put that in the comments. And if you also have any other approach to solve this problem, please put that in the comments as well. I'll surely check on that. And don't forget to subscribe and share this video, guys. Keep streaking.